pretty much just get away with the sine rule, because here's the thing, if I can't use the angle, if that's not the right angle that I need, I know how many degrees are there in a triangle. So this must need 100, 130, 50. 50. So there you go. I don't need to use that rule. You can use that rule by all means, right? Smart kids use that rule. Me, I just get a pen and paper and a protractor and I just draw it out, right? And the best part is, the question, 9 times out of 10, is going to be drawn to scale as well. So it means you don't even need the protractor. There's a little technique that you can use to transfer an angle without getting a protractor out. Nobody likes to use this, but I mean, I love it. But kids, whenever I taught my daughter this week, and she's like, oh, I don't know very much. But I'm like, it's going to save you a whole lot of protractor time. Okay. So we've done a lot of trigonometry this time, right? We've done a lot of trigonometry. The next thing we're going to talk about is forces, or vectors. I really like those triangles. It's sad to see them go, but you know, they're in my head. In my head. And once they're in your head, you don't need to have them drawn on the board anymore. You can just know them all the time. So, my kids in the Year 12 class, they like to talk about boardmasters and how great boardmasters are. Smudgy pens. Anyway, so, look, in fairness, if my Year 12s were seeing this, this was actually not a boardmaster, so the smudgy pen was not the boardmaster. Okay. What we're going to do is we're going to imagine once upon a time there was this kid and she went for a hike, right? And she went north. I'm just going to use the letters from now on because, you know, I don't want to write any more than I have to. She went north 2 kilometers. Okay, 2 kilometers north, right? And then she went 3 kilometers east. And then she went another 2 kilometers north. Can anyone tell me how far away she is from where she started?
Is it displacement or overall distance?
In this case, we're interested in how far she is from where she started. Yeah. I thought you might know this one.
It's going to be... Oh, it's going to be 5 kilometers.
5 kilometers away from where she started. Let's have a look. Okay, so once upon a time there was this kid. She went 2 kilometers north. She went 3 kilometers east. She went another 2 kilometers north.
Yo, isn't that?
Right?
Yeah.
West.
Oh.
Come on.
Okay. How far away are we from where we started? Well, another way of drawing that would be saying, if you just went, the total amount north was 4, and the total amount to the side was 3. How would we add those two vectors together? We talked about this. How do we add when we have a certain amount of vertical and a certain amount of horizontal, or in this case a certain amount of north and a certain amount of horizontal, how do we add the distance together? How do we add those values together? Pythagoras' theorem. Right? So 4 squared plus 3 squared equals 5 squared. Okay, then I said the problem is here, we also need to figure out the angle. Now a lot of people would draw their angle like this, and for a map, yeah, you do actually measure, for surveyors do actually measure from north 0 to 360. But when you're building a structure, you measure it this way. Right? So in this case, we would measure the angle. How would we figure that angle out? Well, for engineers, we're just allowed to draw this. We can literally just get a ruler out. We can draw 2 centimeters across, right? Or we probably draw 2 millimeters. Not 2 millimeters, that's too small. We draw 20 millimeters, 20 millimeters, 30 millimeters, 20 millimeters. Get the ruler out, done. Get the protractor out, done. And we're done. Right? How great is that? So much better than maths. Okay, but let's assume that we're going to do it mathematically. How would we figure out this angle without a protractor? No, you can go to the bathroom if you need to go to the bathroom. No. Do you need to go to the bathroom? Yeah, okay, for that. Okay. How would I figure out that angle?
10, 30 equals.
Oh, this guy. Okay, so for starters, so it's going to be theta equals a tan, or the inverse of tan, and it's going to be the opposite over adjacent. Okay, so which one's opposite theta?
3.
3. And which one's adjacent?
4.
Okay, so can someone type that in? I think this one just did it a second ago. 36 degrees.
Yeah, race.
Oh yeah, 36.
36.8, something like that. There we go. Pretty good. Pretty good. Okay. Nice, nice. Okay. So that's one vector we could add, but typically the vectors we're interested in adding are forces, right? As engineers, typically what we want to do is we want to add force vectors. So let's say I had a truss, right? My good old Warren truss. And then I have an angle, I have a force on here, and this force is like this. Remember, we measure from the horizontal, 30 degrees. And I tell you that this is 100 newtons. Oh, that's going to take you a while.
Unacceptable,
G'day.
boys.
Can anyone tell me, if I wanted to replace that instead, with, I'm just going to draw that part of it, that's truss again. Okay, I'm just trying to make it clear which side is which. Okay, if I wanted to replace that 100, I don't like diagonals. Diagonals are very hard to put in Microsoft Excel. So, how am I going to replace that 100 with a vertical and a horizontal force? Anyone? Nope.
Oh wait, no, trigonometry.
Excellent, okay. So how am I going to find this side here? Let's have a look at this angle, right? We could say that this diagonal can be broken up into its vertical component. If it's going down, well then this has to be going down, yeah? And is this going to the left or the right?
Right.
It's going to the right, so it's going to be going to the right. Okay, we're being told it's 30 degrees.
It's cos 30.
So this side here, the horizontal component, is next to, yeah, so we're going to use cos. We're going to say if this is 100, this is going to be 100 cos 30. This side here is going to be? It's the opposite. Sine, okay? So it's going to be 100 sine 30. But, genius that I am, notice that I do not get a calculator out. How much time did I save? Some amount of time. Okay. Eventually, you're going to, well, okay. In year 11, we think it's fun to make you add lots of vectors. We don't really do it in year 12. In year 12, we just ask you to break things down into the horizontal and vertical components, and then once you've got your answer in horizontal and vertical components, to get that last remaining answer, add them together, and find the angle using?
Trigonometry.
More specifically?
Pythagoras.
Nope.
Right angle trig? Wait, no.
The inverse of tan. Anyway, it doesn't matter, we'll move on. Okay, the point is, in year 11, they get a bit excited. In year 11, they're like, oh, we want to make kids do lots of vector addition, right? They're just like, they're going off with too many vectors. Oh yeah. So what they might do is they might say, if I had 3 different ropes, let's say I had I've got something connected to the ground, right? And connected to that ground, I have 3 different ropes holding in place. 1, 2, and 3. Yeah. Let's just say, for the sake of argument, we'll make these really easy to learn. So this one's horizontal. We did angles in blue, right? So this one's 45 degrees, this one's 60 degrees, and this one's at 0 degrees. And I told you the forces on these were different. So this force here was, I don't know, 6. This one's 7 newtons, and this one here is 8 newtons. I like to make you add these sorts of things. I want to say, I want you to replace all of those ropes. I want you to replace all of those ropes with one rope. One mega rope. The one rope to control them all. Now I'm going to think it's probably going to be somewhere in this direction. I'm drawing this wavy line because I don't really know where it's going to be. But I want to replace all of those ropes with one rope. How am I going to do that? Well, it's just like the story about the girl going for the bushwalk. We'd say, okay, well there's this girl and she went 6 to the left, 6 to the left, and then she went 7. She went 7 at 45 degrees. Yeah. I'm just going to move. I don't want to run out of space. She went 6 to the left. She went 7 at 45 degrees. And then she went 8 at 60 degrees.
Would that 8 be up to the left?
You don't say. I was just trying to draw it as accurately as possible. Now, me, because I own a protractor, unlike maths teachers who don't seem to, burn, is this going to come back? Am I going to have one of these maths teachers come back and say, Hans, we saw your videos and you were a bit mean. We do own protractors, we'll have you know. We could replace that with this. And because I have a protractor, I could just measure it. I could just measure it. I could just measure the angle and measure the force and then say, that's my... We could replace all of these with one rope. But, let's say that we didn't want to do that. Let's say that we wanted to be clever. Well, what I could do, let's say you were like a maths teacher who didn't own a protractor. What you could do here is you could say, well, let's get rid of this diagonal and replace it with a horizontal and vertical. Well, what's 7 times 0.707? What's that? Quick, calculators, go! .9. That'll do. So this one here is going to be 4.9. This one here, okay, can someone give me, what's 8 times 0.866? What's that one?
6.
Sorry?
6.9.
6.9. Okay, so I could then figure out, well, how much vertical have I got? 4.9 plus 6.9 is? How much have I got total?
11.9.
Can't be 11.9.
0.8.
11.8 I can live with. Okay, how far am I from where I started? I start off 6 plus 4 is going to be a total of how much across? 10.9. So how far am I from where I started here? I'm 6.9. So that means I'm going to have a triangle that looks like 11.8 and 6.9. So what's that going to be? Quick, Pythagoreans? Pythagoreans were a cult. They weren't allowed to talk. They swore a vow of silence. They also swore a vow of non-violence, of pacifism. But if you broke the vow of science, they killed you. Okay, what's this one?
13.7.
13.7. Okay, what's this angle? Do we have time for that? Theta equals a tan. Okay, what's the tan? 6.9 divided by 11.8 equals 6.9 divided by 11.8. Yeah, you got it? Quick.
Right.
0.58?
Well, that's what.
I don't think so.
Like the minus stuff.
Yeah, this shit's 10.
Yeah. It's like
It's 10, negative 1. 6.9.
30.3, that I can live with. Okay, So, even though we like to measure our angles from the horizontal, this one here we're going to measure from here. We replaced all of this with, what did we say this was? 13.7 newtons, and the angle is 30 point, what did you say the angle was? 30.3. Okay, before I end this recording, this, when we replace lots of cables with one cable, we have a word for it. Does anyone who does physics, can they tell me? It starts with an R. It's called a resultant. Resultant. A resultant is where you add up the value of all of the forces and you replace it with one force. You replace these 3 wires with 1 wire. Have a great weekend, everybody. See you later.
Thanks, sir.
Off.